In this lesson, we'll examine the use of complements to help make probability calculations easier. So what is a complement? Well, we'll use the following example to introduce this concept. Say we have a box containing 5 red balls and 2 green balls. If we randomly select one ball, the probability that the ball is green is equal to 2/7. Now, what is the probability that the selected ball is not green? Well, 5 of the 7 balls are not green, so the probability is 5/7. Now, if selecting a green ball is an event, then the complement of that event is selecting a ball that isn't green. In general, if an event involves something occurring, then the complement of that event involves that thing not occurring. So if an event is defined as winning a race, then the complement is not winning the race. Now here's the important part. Notice what happens when we take the probability the ball is green and add it to the probability of its complement, the ball is not green. When we do this, we get a sum of 1. Now you don't need to remember the definition of the word complement. However, you should remember these results, which we can generalize as follows. The probability that an event happens plus the probability the event doesn't happen will always equal 1. Or we can rearrange this equation to conclude that the probability that an event happens will always equal 1 minus the probability the event doesn't happen. Now let's look at an example of how this rule works. In this question, we are told that the probability is 0.45 that a randomly selected mouse is male. We want to determine the probability that the mouse is female. Now note that selecting a female mouse is the complement of selecting a male mouse, so we can use the following rule. When we apply this rule, we see that the probability the mouse is female is equal to 1 minus the probability that the mouse is not female. Now the probability that the mouse is not female can be rewritten as the probability the mouse is male. Since the question tells us that the probability is 0.45 that the mouse is male, we can add this to our equation, and when we simplify this, we get 0.55. So the probability is 0.55 that the mouse is female. Now this was a straightforward application. Now let's examine a harder question. Here we are selecting one number from each of 3 sets, and we want to determine the probability that the product of the 3 numbers is even. Now this question is very hard to answer without the use of complements. The difficulty lies in determining the number of selections that have an even product. Here are some possible outcomes where the product of the 3 numbers is even. As you can see, there are many such outcomes, so counting all of them might be difficult. However, this question is much easier to solve when we consider the complement. Now, what is the complement of having a product that is even? The complement is having a product that is not even. In other words, having a product that is odd. Now, in how many different ways can we select 3 numbers such that the product of the 3 numbers is odd? Well, for this to happen, all 3 of our numbers must be odd. Since each set has only one odd number, there is only one selection where the product is odd. So given this, we're going to use complements to solve this question. So the probability that the product is even will be equal to 1 minus the probability that the product is not even. In other words, the probability that the product is odd. So we now need to determine the probability that the product is odd. To do this, we'll use the probability formula. Now we want to determine the number of outcomes where the product is odd and the total number of possible outcomes. As always, we'll begin with the denominator. To calculate the number of possible outcomes, we'll take the task of building outcomes and break it into stages. One stage is selecting a number from the first set, another stage a number from the second set, and another stage a number from the third set. We can accomplish the first stage in 2 ways, the second stage in 5 ways, and the third stage in 4 ways. When we apply the fundamental counting principle, we can see that there are 40 different outcomes. Now we'll tackle the numerator. Here we want to determine how many of the 40 outcomes are such that the product of the three numbers is odd. As we saw earlier, there is only one way to select three numbers and get an odd product. So the numerator here is 1. Now that we have determined that the probability is 1/40th that the product is odd, we can answer our original question, which asks us to find the probability that the product is even. Now that we know the probability the product is odd, we can add this information to our calculations to get 39/40ths. So 39/40ths is the probability that the product of the three numbers will be even. Now in this lesson, we learned the importance of complements. They can be useful if you find that calculating the probability that an event does not occur is easier than calculating the probability an event does occur. Also, in questions involving at least and at most, you may find it beneficial to consider the complement of an event.